What are all positive values of p such that the series converges? So let's see, we have the sum from n equals 1 to infinity of negative 1 to the n plus 1 times p over 6 to the n. So there's a couple of things that might jump out at you. This negative 1 to the n plus 1, as n goes from 1 to 2 to 3, this is just going to alternate between positive 1, negative 1, positive 1, negative 1. So we're going to have alternating signs. So that might be a little bit of a clue of what's going on. And actually, let's just write it out. This is going to be, see, when n equals 1, this is going to be to the second power. So it's going to be positive 1. So it's going to be p over 6. And then when n is 2, this is going to be to the third power. So it's going to be minus p over 6 squared, then plus p over 6 to the third power, and I could even write to the first power right over here, then minus p over 6 to the fourth power, and we're going to just keep going plus minus on and on and on and on forever. So this is clearly, this is a classic alternating series right over here, and so we can actually apply our alternating series test. And our alternating series test tells us that if this part of our expression, the part that is not alternating in sign, I guess you could say, if this part of the expression is monotonically decreasing, monotonically decreasing, which is just a fancy way of saying that each successive term is less than the term before it. And if we also know that the limit of this as n approaches infinity, that also has to be equal to 0. So the limit as n approaches infinity of p over 6 to the nth power also has to be equal to 0. So under what conditions is that going to be true? Well, to meet either one of those conditions, p over 6 has to be less than 1. If p over 6 was equal to 1, if, for example, p was 6, well, then we wouldn't be monotonically decreasing. Every term here would just be 1. It would be 1 to the 1, 1 squared, on and on and on. And if p is greater than 6, well, then every time we multiply by p over 6 again, we would get a larger number over and over again. And the limit, for sure, would not be equal to 0. So we could say p over 6 needs to be less than 1. And so multiply both sides by 6, and you get p needs to be less than 6. And they told us, for what are all the positive values of p? So we also know that p has to be greater than 0. So p is greater than 0 and less than 6, which is that choice right over here. And once again, we're not going to say less than or equal to 6, because if p was equal to 6, this term is going to be 1 to the n. And so we're just going to have, this would be 1, this would be 1. It would be 1 minus 1 plus 1, on and on and on and on forever. So definitely like that first choice.